everything in our universe is made from fundamental particles. Its immensity is filled with microscopic mysteries. For 7 years, CERN scientists have been working to unveil its secrets, making it the world's largest center for particle physics. At CERN's foundation in 1954, scientists were trying to come to grips with the plethora of particles observed in nature. They lacked an overall framework to explain these basic constituents of matter and the forces that act upon them. This framework would later become known as the Standard Model. Studying the infinitely small meant building experiments the size of monuments.
À Mérin, près de Genève, se trouve le plus grand chantier que l'Europe ait jamais vu. Il s'agit de la construction du Centre européen de recherche nucléaire.
In 1958, the SC, CERN's first accelerator, showed clear evidence of a rare particle transformation, the anomalous pion decay, which had been predicted by the theory but never observed. The PS first accelerated protons in 1959, becoming the world's most powerful accelerator.
Cette machine circulaire accélère des protons, des noyaux d'atomes d'hydrogène, leur imprimant une vitesse voisine de celle de la lumière, environ 300 000 km par seconde, et pouvant leur impartir une énergie maximum de 28 000 millions d'électronvolts.
In 1973, the Gargamel bubble chamber, which received a muon neutrino beam from the PS, proved the existence of weak neutral currents. This major discovery solidified the foundations of the early Standard Model of particle physics.
Les chambres à deux conduisaient la communauté à laquelle j'appartenais à avoir chaque année 10 millions de photographies à analyser.
In 1968, George Sharpak developed the multi-wire proportional chamber, which revolutionized particle detection, heralding the electronic era.
Le prix Nobel de physique de l'année 1992 vous a été décerné pour votre invention et développement de détecteurs de particules.
In 1971, strong interaction between quarks was revealed in CERN's first proton-proton collider, the ISR.
The ISR was the first hadron collider ever built and operated.
The SPS was switched on for the first time in 1976. It was then transformed from a one-beam accelerator into a proton-antiproton collider.
L'Académie royale des sciences de Suède a décidé d'attribuer le prix Nobel de physique 1984 conjointement au professeur Carlo Rubbia et au docteur Simon van der Meer pour leur contribution décisive au grand projet qui a conduit à la découverte des particules de champ W et Z, médiateurs de l'interaction faible.
The Large Electron Positron Collider, LEP, was the largest scientific instrument ever built, and its tunnel, Europe's largest civil engineering project.
One of LEP's most important results was an extraordinary measurement of nature's deep properties, the existence of exactly 3 families of quarks and leptons, crucial for understanding the deeper workings of our universe. The size of the LEP collaboration was many times larger than any previous experiment. This created the need for a new universal way of exchanging data among physicists, setting the scene for the invention of the web. In 1995, at CERN's Lear facility, for the first time scientists brought together antimatter particles, forming the first atoms of antihydrogen. In the year 2000, CERN announced the observation of a new state of matter known as quark-gluon plasma. This state of matter prevailed when the universe was only a billionth of a second old.
We have a discovery. We have observed a new particle consistent with a Higgs boson. As a layman, I would now say, I think we have it.
I would like to add my congratulations to everybody involved in this tremendous achievement.
This year's prize is about something very small that makes all the difference.
In the wake of this groundbreaking discovery, The LHC's quest for knowledge deepens, unveiling particles that defy convention and challenge our understanding of the subatomic world. With unprecedented precision, the LHC delineates the Higgs boson's identity, probing its mass, spin, and the subtle ways it influences other particles, seeking signs of new phenomena. We peer into our universe's dawn through quark-gluon plasma, recreated in heavy ion collisions. Yet, the universe keeps its secrets. As the searches for supersymmetry, dark matter, and hidden dimensions continue without definitive proof, but ever advancing the frontiers of physics. As we stand on the brink of tomorrow, the LHC's legacy paves the way for the next generation of accelerators.
We believe very firmly that to continue this search in the unknown, we will need a much larger accelerator at a much higher energy.
The journey is far from over.